Using the Gauss Jordan elimination method, find the point of intersection of the following system of planes. X minus y plus 2z is equal to 4, 3x plus 2y minus z is equal to 5, 2x plus 3y plus z is equal to minus 5. So writing the planes out like that, okay, and then form the matrix. So the matrix you form from taking the coefficients of each one. So you get 1, minus 1, 2, etc. You can see 1, minus 1, 2, 3, 2, minus 1, 2, 3, 1. By the way, I like to write my z with a line through them, not to confuse them with the number 2, times x plus y, so you get row times column, which will give you that, must be equal to 4. And then you can see where these numbers come from. So the idea is we now find the inverse of this matrix, multiply it on this side, and get the value of x, y, and z. So if we let m be equal to the matrix, we need to find the m to the minus 1. Okay, so we will use this method called the Gauss Jordan elimination method. Gauss Jordan elimination method. I wouldn't really recommend this method, but I want to show you how to do it. Okay, so setting it out, you write the matrix on this side, you draw a line, and then on the right hand side you write the identity matrix. And the idea is that you need to move that by doing row operations over to this side. So we're going to label them row 1, row 2, row 3. Right, so step 1 is you need to make these two here elements 0. So making the first element in the next two rows equal to 0, well, I've highlighted there. So in order to do that, we're going to react with row 1. I just need to do, the new row 2 will be row 2 minus 3 row 1. You can see that will give 0. But you have to do it to every pair of elements in this matrix. So that gives that 0, 5 minus 7. So here you're going to get 2 minus 3, which will give you 5. And then you're going to get minus 1 minus 3 times 2, which gives you minus 7. And then you also need to do it to these ones here. So here you're going to get minus 3, 1, and 0. And then we need to do the new row 3, which is going to be row 3 minus 2 row 1. That will make this 0. Okay, so the next one will be 3 minus 2 times minus 1, which will make that 5, minus 3, minus 2, and 1. I'm not doing all the arithmetic, but you can just follow it through. Right, so I'm going to just write that one out again. Okay, and now the next thing we're going to do is we're going to make this element here, we're going to make that a 0. So the new row 1 will be 7 row 1 plus 2 row 2. Okay, so that will make 7 plus 0 minus 7 plus 10, which will make 3, and then you can see, very easy to see that 2 times 7 minus 2 times 7 will give you 0. Again, you need to do it to these ones here. That will give you 1, 2, and 0. Row 2 we're just going to keep the same at the moment, and then we're going to make this element here equal to 0 by doing new row 3 by row 3 minus row 2, and then if we use that, that will ensure that these two keep as 0. So the first element will be 0, and then if you do 5 minus 5 you get 0. Minus 4 minus 7 is 4, and again you do it for these ones here to get these numbers here. Okay, so carrying on, so row 1 will be 7, 3, 0, 1, 2, 0. We're going to have make this one here now 0. So in order to do that, we're going to do 4 row 2 plus row 3. So just going to act with these two here again. That will ensure that these stay, all the ones there stay 0. So we're going to get 0, 20, that will be 0. So that will be 4 times minus 7 plus 7 times 4, which gives you 0 there. And again, you need to do it to these ones here. Okay, we'll keep row 3 the same. So we're just left with this, making this 3 equal to a 0. Okay, so we're going to do that by doing 20 row 1 minus 3 row 2 on the previous ones here. So that will give me 140. Then we'll make that 0, 0, and then you need to apply it to all these as well. And then the other two rows we're just going to keep as they are in the previous matrix. Okay, so we're nearly there. We just need to make these all 1. Okay, so write that out again on the previous slide. Okay, so first row we just need to divide by 140 each element. That will make that 100. We get 0.25, 0.35 minus 0.15. The next one we'll need to divide by 20. You're going to get 0, 1, 0 minus 0.25 minus 0.25 minus 0.35. And then the next one, 1/4 times row 3, which will give you 0, 0, 1, 0.25 minus 0.25, 0.25. Okay, so here we now have the identity matrix, and this now represents the inverse matrix. So we now have got the inverse matrix, so all we need to do is find x, y, z, take the inverse matrix, multiply it by the numbers on the end of the planes. That will give me x, y, and z, 3.5 minus 3.5, 1.5, and the planes will meet at the point 3.5 minus 3.5 minus 1.5. Okay. To actually see what it looks like, so here we have in GeoGebra app, which I'll put on the link I'll put on the notes of the video. Okay, so here we have the idea, the three planes, the matrix representation, and then doing the inverse times these numbers at the end will give you the point of intersection, which is actually here, at this point here. There they are as fractions. Okay, if we move this around a bit, maybe you can see it a bit better. You can see very clearly that these three planes actually meet at that particular point. Okay. This has been a video to show you how to use the Gauss Jordan method for row elimination to find the inverse matrix of a 3x3 matrix. I hope you have understood it, and I thank you very much for watching, and maybe I can consider you to subscribe to my channel, where you will find absolutely thousands of maths videos to help you from Key Stage 3 to A-level further maths. Anyhow, thank you very much for watching, and I'll see you in the next one. Bye-bye.